Okay, guys, welcome back to Math 1050 here at Wayne State, Math 1800 at Wayne State University. This is the pre-calculus course offered here. My name is Rush Mahaber. I wanted to go through some of the motions that involved in graphing higher normal polynomials. Now, why are we interested in this? Because sometimes, if you have a degree 2, we talk about what that looked at, degree 3, but what if you have a degree 7? You know, a guy that looks like, I don't know, what does a degree 7 look like? It can vary from shape to shape. So we want to look at higher degree polynomials. And what is a guy that's an example of a higher degree polynomial? Well, look something like this. How about p of x equals, how about x cubed, that's negative, plus 2x squared plus 15x, right? Like how would we even graph that or go about approaching that? Well, many times before, especially in section 1.8, which was the whole nonlinear inequalities that we talked about in the past, right? The whole idea of like finding a domain using the nonlinear inequalities and figuring out what the solution was of stuff, right? As well as finding the domain of things in section 2.2, we used this idea of a sign chart, right? Well, that's what it's used for, but that's just one of the methods or reasons, one of the ways we use a sign chart, okay? This is truly, and this is why I always say we do a sign chart on a function. We're not solving a nonlinear inequality here, but we're going to need a sign chart. So in order to graph this, and I'm just going to jump right into it because I think you guys definitely can handle this. Draw. Okay, so in order to graph this polynomial, okay, we only need to find two things. One is the intercepts, and we have two different types of intercepts, which is your x-intercepts and the y-intercepts. And last but not least, we're going to have to make a sign chart. Now, this is not all that complex, but there's some details here that you're going to have to pay attention to. Okay, and a couple bits of terminology that I will introduce as we hit certain topics within the section. Okay, so first things first. Okay, we need to figure out what the x and y intercepts are. So one thing that you'll always find very, very helpful is to factor this as much as possible. Factor as much as possible. But let's pretend that we didn't do that. We didn't factor it, okay? It's not going to change anything. It's just going to make the computations a little harder. I tend to like things a little easier. Maybe it's better we leave it harder. All right. So number one, let's find our intercepts. Okay. First things first is I want to find my y-intercept. Okay, y-intercept. Y-intercept, which guy is 0? Oh, here we go. Back to this again, right? So if you remember section 2.5, when we talked about transformations, like finding x and y intercepts of different functions, the y-intercept, how we find it, is by setting the x equal to 0 and then solving for y. So let's set the x equal to 0. Because this is a function, I'm going to plug it into the function. This gives me 0, 0, 0. Actually, it's all zeros. That worked out pretty well. You actually can do this in your head. You really don't even need to show any work. So I'm actually just going to erase all this because I didn't even show any work. That's a 0. Let's do the x-intercept. Now, the x-intercept is just the opposite. What is the x when y is 0? So let's make our function p of x, which is y, equal to 0, right? And that's what I'm going to do. So p of x, which is y, equals 0. And this ends up giving you negative x cubed plus 2x squared plus 15x. Can we solve this? All right, ladies and gentlemen, here we go. I'm going to factor out a negative x out of this. Why a negative x? Because I want to keep this positive. So it gives me x squared minus 2x minus 15 equal to 0. Does this factor? I think it does, by golly. Negative what's that, 5 and positive 3. That worked out okay, right? So this is why I said it's kind of helpful when you factor it up front, because that's what this would have factored into, and then you could have just jumped right here, and you get x equals 0, x equals 5, x equals negative 3. So you get 3 x-intercepts, which is this, and this. Now this is where I'm going to introduce a term to you. And this term is called multiplicity. And it's not a big term, but it's an important one. Multiplicity. A multiplicity is the idea that a duplicate root has occurred. So for example, if this was an x squared, there'd be two zeros here, even though you'd solve it, and you won't say x equals 0 twice, right? It just lets you know that you have a duplicate root. Now, you're probably saying that, why do I need to know this? Well, it has really big bearings on how the picture will look. Okay, so the multiplicity here is going to be 1, 1, and 1, because if you notice, they all occurred at 1. Okay, so that's the first thing we do. The second thing we do is then find the sign chart. So here we go. Here's the sign chart. All right, so here's a question. Do you remember how to make a sign chart? Well, yes, I hope you guys do. That means you need to look for zeros and undefineds. Right? The zeros is what makes the function equal to 0. You notice anything familiar here? So by knowing the x-intercepts, you actually know the zeros. And I've been saying this for a while. Zeros and x-intercepts are the same thing. So this lets me know my zeros are literally these numbers. X equals 0, x equals 5, x equals -3. And because this is a polynomial, we don't have a denominator. Since we don't have a denominator, we have nothing to set equal to 0, so we have none of these. We will get these in 3.6 when we actually start doing rational graphing, right? Rational polynomials. So let's make our sign chart finally. And so our zeros, which are here, and what will be labeled here, is going to be, let's see, -3, 0, and 5. So these are zeros, zeros, and zeros. Now, here's the cool part. My multiplicities, I'm actually going to write underneath the zeros. So my multiplicities, I'll write them in the same color. That way we don't get confused on what the numbers mean. Check this out. Plug in one of these. Okay, one of these. So I'm going to plug in, I guess, because remember, we have to figure out what the signs are in between these intervals. Let's plug in -4. We get -4 cubed, but in all, when we do this, we end up getting a negative here. Okay? Good news. By finding one of these, and this is another key piece that you need to keep on your paper, okay, around multiplicities, right? So zeros and x-intercepts aren't really a new concept. Sign charts really are a new concept, but most people always wondered how I was able to do sign charts so quickly without even going through the motions of stuff, right? And this is how I knew what was what, and this is the key. The key is this: for multiplicities, if a root has an even multiplicity, then even, meaning 2, 4, 6, 8, 10, then the sign stays the same. If it is odd, the sign alternates. So, check this out. The multiplicity in all of these are 1. So I know just off of knowing this one, and this is one that's very, very important, because if you screw up on this one, everything else is going to be wrong. Okay? So, if that one's negative, then I know this for sure, that because this is an odd multiplicity, odd multiplicity, this will be a positive. It alternates. This is odd, right? So it alternates. This is odd. It alternates. If this was like a multiplicity of 2, this one's negative, stays the same. Bingo. Okay? So it's not really a hard concept of figuring out what the signs are, but then it takes out a lot of the medial calculations. So you only got to figure out one, and then life is good. So what does this mean? Now we are finally in a place to graph this. All right, guys, so here we go. Here's my graph. Let me not screw it up. Okay, so that's it. Whatever's here in your intercepts need to also be here. So 0, 0, -3, 0, 1, 2, 3, 4, 5, 0. Now, here's something that's cool. The multiplicities also tell you what the shape of the root looks like. And because these are all multiplicity 1, that's a linear. That's degree 1. So that means your roots here, once again, this idea of multiplicity is huge. The roots here is going to go from a negative. Guys, I'm afraid I screwed up the sign chart. Let's try this one more time. This is positive, which makes this negative, which makes this positive, which makes this negative. How do I know this? Because I kind of already know what this thing should look like, and I just put the wrong sign there. Sorry, guys. All right, so obviously it's degree 1. What do degree 1s look like? Well, that's a linear guy. It's a straight line. So that means at negative 3, it's going to be degree 1 looking. So that means it looks like this. And why does it look like that? It'll be positive on the left side, meaning above the x-axis, and negative on the right side, meaning below the x-axis. Let's look at 0. It'll be negative, meaning below the x-axis. And then on the other side, it's positive, but all looking straight line-like. And then finally, for 5, it's positive, and then negative. See? Fairly simple. Okay? So then, what do? Well, connect the dots, and we're ready to rock and roll. So watch what I do here. That's the graph of your function. It's really, really simple, isn't it, guys? Okay? Just got to watch out for making those sign errors on the sign chart. It's really, really not all that hard. Let's do one more, and this time I'm going to do something that actually has more of an even multiplicity, so you can kind of get an idea of what's going on. And I'm actually going to be nice and give it to you already in factored form. Okay, so let's graph this guy. Sketch the graph of this guy. F of x equals negative x plus 2 squared times x minus 1 times x minus 1 plus 1 cubed. All right. So here we go. Now, when it's like this, you're ready to rock and roll. So let's see how good you guys are. Let's find our intercepts. All right. So for my y-intercept, who's 0? X or y? X is 0. Let's see, can you do this mentally? 0 plus 2 squared is 4. Hold it. Negative 1, and that negative in the front will give you a positive 4. 0 plus 1 is 1 cubed is 1 times the 4, so that still just gives you a 4. Okay? Now, if you didn't get that, you better show all the work by plugging the numbers in. Arithmetic reigns supreme, ladies and gentlemen. Now, if you set this equal to 0 and solve, right, because that's how you find your x-intercepts, what do you end up getting? You should see this is going to be negative 2. This is going to be 1. And then this is going to be negative 1. Now, here's something that's cool. What is the multiplicities on these? This one is multiplicity 2, 2 duplicates. This one's multiplicity 1. This one's multiplicity 3. See? It's really not all that hard once it already goes in that factor form. So always try to factor this blob. Number 2, let's make the sign chart. Now, once again, if you're already looking ahead, you're going to have zeros, right? But your zeros, we're really going to stop calling these zeros and start calling them x-intercepts, because that's really what they are, is x-intercepts. So for your x-intercepts, what are you going to have? Well, you're going to have negative 1. Well, let me put it in order. Negative 2, negative 1, and 1. Now notice these are all zeros. Now why didn't I even bother writing undefined? It's because I don't have a denominator. I'm not going to have any, but I'll do it for you. So I have none of these. Okay? Now, I just need the sign. Now let's see who's paying attention. I know one of these. Which one do I know? Didn't I go through the trouble of solving the y-intercept, plugging in 0 and getting out a positive 4? So if I plugged in 0 and got a positive 4, that means his 0 is normally here, and I got a positive for in here. That's something, but that's all I need to figure out the rest of the signs. Why? The multiplicity here is 2, multiplicity here is 3, and multiplicity here is 1. And what do we know from before? An even root has an even, well, if a root has an even multiplicity, the signs stay the same. And if an odd root, it is going to alternate. So this is odd, alternates. Odd, alternates. Even should stay the same. All right. Pretty easy, right? Now let's graph it. Now remember, the multiplicity is also going to help us graph this guy. So let me get my black pen out. It's all about the multiplicity, ladies and gentlemen. So that tells me at -2, here's -1, here's 1. I have zeros here. Boom, boom. So anything that's here needs to go. Right? 0, 1, 2, 3, and 4. Okay? Now it tells me that on the left, at -2, I have multiplicity 2. What does a degree 2 look like? It looks like a quadratic, doesn't it? Well, and they're both negative. So that means that this is going to be here and here. See how it looks quadratic around the root? So it should be. Watch this guy. This guy's degree 3. What do degree 3s look like? Oh yeah, you're darn tootin'. Looks kind of like this. So it'll be negative down here and then positive up there. Boom. See that? And finally, degree 1s are straight lines. They're going positive and negative, which means it starts above the x-axis and comes below the x-axis. All right, now, here we go. What do we got to do? Finish it off. Just connect the dots, ladies and gentlemen. Here's the green light. So watch this. Should go through this point, right? It's our y-intercept. And this goes down forever, this goes down forever. And there's our general sketch of the graph. So notice the behavior around the root is described by the multiplicity. So this is actually probably one of the best things about graphing that I absolutely love, is that the multiplicity tells you what's going to happen and how it's going to happen as you get closer. But this is where you get those shapes. And guess what? When you learn about a derivative, the contour of the graph, meaning how it turns, gets even more specific, which actually is a beautiful thing. You learn about something called concavity, and when it's increasing and decreasing, it becomes a much more efficient thing. All right, guys. So here's one for class, and now I'll talk about it in class, and I'll actually probably even collect it from you. And if you want, you can attempt to send me an email. Here we go. I want you to sketch the graph of x minus 4 squared, x plus 1 squared. Once again, if you already got this guy factored, this should be like easy peasy. What do I mean by that? You should be able to look at it and just find the intercepts. You should be able to look at it and find so the x-intercept and y-intercept, and then make the sign chart. All from just looking at it and then using multiplicities. That's really the big point here. To go through and use the multiplicities to make your sign chart and then to graph it. It should be an easy problem. All right, guys. In order to go somewhere you haven't been and do some stuff you've never done, you must become open-minded and actually push hard. But don't be afraid to really go towards your fears when you learn something new. Okay, and be inquisitive. Mathematics is always about being inquisitive. All right. So if you have any questions, by all means, feel free to email me or come see me during office hours. This is Rush Mahaber signing off. Have a good day.